exploring the quantum mystery, the double-slit experiment unveiled. In the grand tapestry of the universe, there exists a realm that defies common sense, a realm where particles dance to the beat of quantum mechanics. Our story unfolds within the confines of a laboratory, a sacred space where scientists embark on a journey into the mysterious world of the double-slit experiment. As we step into this scientific theater, envision a realm where the ordinary laws of physics take an unexpected turn. It is a domain where particles, those minuscule building blocks of matter, defy the expectations of classical physics and perform a mesmerizing dance of uncertainty. The laboratory is a bustling hub of activity, filled with the hum of machinery and the focused energy of scientists dedicated to unraveling the secrets of the quantum world. Amongst the sophisticated instruments and cutting-edge technology, the double-slit experiment takes center stage, an experiment that challenges our very understanding of reality. In this setting, scientists clad in lab coats meticulously prepare for their exploration. The air is charged with intellectual curiosity and anticipation. The laboratory becomes a portal to a universe governed by probabilities, where the seemingly straightforward nature of particles transforms into a perplexing dance of waves and particles. As the scientists fine-tune the experimental apparatus, they prepare to launch particles, such as electrons or photons, into a world where the ordinary rules no longer apply. The laboratory becomes a theater of the absurd, where the quantum stage is set and the double-slit apparatus stands as the gateway to a world of perplexity and wonder. In this cosmic theater, the stage is set, and the actors, particles on the quantum stage, await their cue to perform. The laboratory, a crucible of discovery, becomes a space where the boundaries of classical and quantum physics blur, paving the way for a tale that challenges our fundamental understanding of the nature of reality. As we immerse ourselves in the atmosphere of scientific inquiry, we witness the birth of questions that defy easy answers. What happens when particles are not confined to the predictable trajectories we've come to expect? How does the act of observation influence the behavior of these quantum actors? The laboratory, with its controlled chaos and intellectual fervor, becomes the backdrop for a story that transcends the limits of our everyday experience. And so, with the laboratory as our stage and the double-slit experiment as our narrative compass, we embark on a journey into the heart of quantum mystery, a journey that challenges our perceptions, expands our understanding, and beckons us to explore the frontiers of the unknown. The curtain rises, and the double-slit experiment takes center stage, inviting us to witness the unveiling of the enigmatic dance of particles in the theater of the quantum realm. Now that the stage is set, let's turn our attention to the protagonist of our story, the double-slit experiment. Imagine a canvas, a screen, where two minuscule slits are delicately etched. These slits, like secret passages into the quantum realm, are the entry points for our actors, the particles, to traverse. The experimental apparatus, seemingly simple in design, carries profound implications for our understanding of the quantum world. On one side, a source releases particles, one at a time, with the precision of a cosmic heartbeat. The particles, let's say electrons, embark on a journey towards the awaiting slits. As a single electron approaches the double-slit screen, something extraordinary happens. Contrary to our classical intuition, the electron doesn't behave like a tiny billiard ball, obediently choosing one slit or the other. Instead, it assumes a more ethereal form, a wave. Yes, a wave. The electron, in a twist that challenges the very essence of our understanding, decides to explore both slits simultaneously. It's as if the electron is a nimble dancer, pirouetting through both openings with a grace that defies the laws of classical physics. The consequence of this wave-like behavior becomes evident as the electron moves beyond the slits. On the other side, a detector screen eagerly awaits, ready to capture the footprints of our quantum dancer. And what appears on the screen is nothing short of magical, an interference pattern. This pattern, a series of alternating bright and dark bands, tells a tale of waves overlapping, creating peaks and troughs. The interference pattern is the calling card of wave-like behavior, a phenomenon that classical particles with their well-defined trajectories would never exhibit. But the intrigue deepens. If we were to close one of the slits, the interference pattern vanishes and the electron behaves as expected, a particle following a predictable path. Open both slits again and the interference pattern returns, as if the electron is aware of the options before it. This peculiar behavior challenges our classical intuition and beckons us to dive deeper into the quantum rabbit hole. The double-slit experiment, with its simple yet profound setup, unfolds a narrative where particles defy our expectations, inviting us to question the very nature of reality. In this quantum theater, the double-slit apparatus stands as a silent witness to the cosmic dance of particles, beckoning scientists to unravel the secrets concealed within its seemingly unassuming structure. As we peer into the heart of the experiment, we find ourselves on the precipice of a quantum adventure, ready to explore the mysteries that await beyond the slits. As we delve deeper into the mesmerizing dance of particles, the spotlight shines on a single electron, making its solitary journey through the double slits. Picture this electron as a solitary traveler, navigating a quantum landscape with the potential for infinite paths. Approaching the double-slit screen, the electron exhibits a behavior that challenges the very foundations of classical physics. Rather than choosing a definitive path, the electron, in a display of quantum grace, takes both paths at the same time. It's as though this tiny traveler possesses the innate ability to explore multiple destinies concurrently. The notion of the electron as a wave comes to life as it passes through both slits simultaneously, creating ripples in the fabric of the quantum realm. These ripples, akin to the undulating waves on a serene pond, hold the key to the enigmatic interference pattern that awaits on the other side of the slits. Imagine the electron as a ghostly entity, its presence felt at multiple points along its trajectory. This wave-like behavior results in a complex pattern on the detector screen, bright bands where the waves reinforce each other, and dark bands where they cancel out. This interference pattern is the telltale signature of the quantum wave nature of the electron. The screen, now a canvas painted with the strokes of quantum probability, becomes a silent witness to the dual nature of the particle, a manifestation of both wave and particle characteristics. As the electron's journey unfolds, it leaves behind a tapestry of probability, challenging our traditional understanding of particles as solid, predictable entities. The dance of the electron, choosing both paths simultaneously, invites us to reconsider our classical intuition and embrace the inherent uncertainty woven into the fabric of the quantum world. But the plot thickens. If we were to close one of the slits, something extraordinary happens. The interference pattern disappears. The electron, deprived of the choice between two paths, reverts to behaving as a classical particle with a well-defined trajectory. Open both slits again, and the interference pattern re-emerges, as if the electron possesses the quantum prowess to adapt its behavior based on the experimental conditions. This peculiar ability of the electron to morph between wave and particle, depending on the experimental setup, leaves scientists pondering the fundamental nature of reality itself. The double-slit experiment, with its tale of a single electron traversing two paths simultaneously, challenges our understanding of determinism and introduces us to a quantum realm where uncertainty reigns supreme. As we witness the electron's quantum ballet, we are beckoned to explore further, to unravel the intricacies of the mysterious dance between particles and waves in the cosmic theater of the double-slit experiment. Our quantum journey takes an intriguing turn as we explore the aftermath of the electron's dual-path adventure through the double slits. Picture the electron's wave-like essence creating ripples on the detector screen on the other side, a canvas poised to reveal the secrets of the quantum dance. As the electron waves pass through the slits and collide on the detector screen, they produce a mesmerizing pattern, an interference pattern. It's a visual symphony of alternating bright and dark bands, a manifestation of the quantum choreography that unfolds when particles embrace their wave-like nature. The bright bands represent points where the waves are in harmony, their peaks and troughs aligning to create constructive interference. In these regions, the amplitude of the waves intensifies, leaving a vibrant imprint on the detector screen. Conversely, the dark bands signify points where the waves are out of sync, cancelling each other out through destructive interference. This interference pattern is the quantum fingerprint, the hallmark of wave-like behavior. It's as if the electron, in its simultaneous exploration of both paths, leaves a trail of interference that captures the essence of its probabilistic journey. As we gaze upon this visual spectacle, we realize that the interference pattern challenges our classical notions of particles as distinct, localized entities. Instead, it introduces us to a quantum landscape where the boundaries between paths blur and the electron exists in a state of superposition, simultaneously taking multiple trajectories. This enigmatic pattern is a testament to the inherent uncertainty woven into the fabric of the quantum world. It's a manifestation of the quantum dance, where particles exhibit a fluidity that transcends our classical expectations. The interference pattern becomes a silent poet, narrating the story of particles embracing their wave-like nature and defying the deterministic scripts of classical physics. But our quantum adventure doesn't end here. It takes a twist that deepens the mystery. If we were to close one of the slits, the interference pattern vanishes, and the detector screen displays a pattern consistent with classical particle behavior, a straightforward distribution of hits without the mesmerizing interference fringes. Closing one slit transforms the quantum dancer into a predictable performer, following a singular path as if the other option never existed. It's a transformation that challenges our intuition and prompts us to question the quantum nature of reality. Open both slits again, and the interference pattern returns with its intricate dance of light and shadow. The electron, it seems, is aware of the experimental conditions, adjusting its behavior based on whether one or both slits are open. This adaptability hints at a quantum intelligence that challenges our understanding of particles as passive entities and invites us to contemplate the dynamic interplay between observation and the quantum realm. The interference pattern, etched on the detector screen, becomes a tableau of quantum wonder, a visual testament to the delicate balance between particle and wave, certainty and probability. It beckons us to peer deeper into the quantum abyss, where the dance of particles continues to defy our expectations, leaving us with more questions than answers. As we stand on the precipice of the quantum realm, the interference pattern serves as a guide, a cryptic map inviting us to explore the uncharted territories of the double-slit experiment. The dance of particles and the emergence of the interference pattern propel us further into the heart of the quantum mystery, where the cosmic ballet of electrons challenges our understanding of reality itself. As the interference pattern captivates our gaze, the plot thickens, and scientists find themselves in a perplexing quandary. Closing one slit removes the mesmerizing interference, reverting the electron to a predictable particle. Open both slits and the interference pattern returns, a testament to the quantum duality of the electron. This quantum twist prompts scientists to ponder the nature of the electron's awareness. Does the electron possess a mysterious consciousness that guides its behavior, adapting to the experimental conditions? Or is it the act of observation itself that influences the outcome? Scratching their heads in collective bewilderment, scientists grapple with the implications. The electron, it seems, is not a passive player in this quantum drama, but a dynamic entity responsive to the experimental stage on which it performs. The double-slit experiment, rather than providing answers, introduces a cascade of questions, inviting scientists to unravel the intricacies of the quantum enigma. The stage is set for the next act, where the mysterious relationship between observation and the behavior of particles takes center stage in our quantum narrative. As our quantum saga unfolds, the role of observation emerges as a pivotal element, casting a profound influence on the behavior of particles. Imagine a scientist standing by, observing the electron's journey through the double slits. The mere act of observation becomes a transformative force, shaping the quantum dance in ways that challenge our deepest intuitions. When scientists introduce a detector to determine which slit the electron passes through, a remarkable shift occurs. The interference pattern, that intricate dance of light and shadow, vanishes. The electron, once a wave gracefully traversing both paths, now behaves like a classical particle, choosing a single slit with certainty. It's as if the electron, aware of being watched, abandons its quantum ambiguity and succumbs to the probing eyes of the observer. The very act of measurement collapses the wave-like superposition, forcing the electron to adopt a singular, well-defined trajectory. This phenomenon, known as the observer effect, invites contemplation on the intimate connection between observation and the behavior of quantum entities. The electron, once dancing freely in the quantum ballet, bows to the influence of the observer, transforming its probabilistic existence into a deterministic reality. This revelation leaves scientists grappling with the nature of observation. Does it simply unveil the inherent state of the particle, or does it actively shape that state? The observer effect challenges our fundamental understanding of reality, highlighting the intricacies of the quantum realm and the elusive nature of particles. In this quantum theater, the observer becomes an integral player, casting a spotlight on the delicate interplay between consciousness and the behavior of particles. The double-slit experiment, once a simple setup, becomes a stage where the mysteries of the quantum world unfold, inviting us to ponder the profound implications of our role as observers in the cosmic drama of particles and waves. As we delve deeper into the quantum mystery, the observer effect takes center stage, reshaping our understanding of reality. Imagine a scientist, armed with a detector, poised to witness the electron's journey through the double slits. The introduction of the observer becomes a transformative act, unveiling the intricate connection between observation and the behavior of particles. In the presence of the observer, armed with the detecting apparatus, the once beautiful interference pattern dissipates. The electron, once a quantum dancer gracefully exploring multiple paths, relinquishes its wave-like ambiguity. Instead, it adheres to a defined trajectory, behaving like a classical particle with predictable precision. This astonishing transformation is the heart of the observer effect. The act of observation collapses the electron's quantum superposition, pushing it into a single, well-defined state. It's as though the mere gaze of the observer forces the electron to abandon its probabilistic nature and adopt a specific outcome, presenting a stark departure from the fluid dance of waves witnessed in the absence of observation. This revelation prompts profound questions about the nature of observation in the quantum realm. Does observation merely unveil the inherent state of the particle, or does it actively mold that state? The observer effect challenges our fundamental notions of causality and unveils the delicate interplay between consciousness and the behavior of particles. In the cosmic theater of the double-slit experiment, the observer becomes a central character, wielding the power to shape the quantum reality. The scientist, once a passive witness, emerges as an active participant in the quantum drama. The experiment highlights the elusive nature of particles, suggesting that their behavior is intimately linked to the act of observation. As scientists grapple with the implications of the observer effect, the quantum stage becomes a battleground of ideas. Some interpret the observer effect as evidence that consciousness plays a fundamental role in the unfolding of quantum events, while others seek alternative explanations, exploring the intricate dance between particles and their environment. The double-slit experiment, once a beacon of simplicity, now stands as a testament to the complexity of the quantum world. The observer effect challenges us to rethink our place in the cosmic narrative, inviting us to consider the dynamic relationship between the observer and the observed in the enigmatic theater of quantum mechanics. As we ponder the implications of the observer effect, the journey into the heart of quantum mystery takes a fascinating and introspective turn, urging us to explore the profound connections between our consciousness and the behavior of particles on the quantum stage. In the wake of the observer effect, scientists grapple with interpreting the peculiarities of the double-slit experiment. The stage is now set for a symphony of ideas, where theories and interpretations intertwine like cosmic threads. One intriguing hypothesis emerges, the notion of parallel universes. Some scientists propose that in the quantum realm, each potential outcome exists in a separate universe. The electron, navigating multiple paths, creates a branching web of parallel realities. This multiverse concept expands the scope of our understanding, suggesting that every choice, every possibility, spawns its own universe. As scientists gather to discuss these radical interpretations, the laboratory becomes a crucible of intellectual exchange. Debates flourish, and competing theories vie for dominance. Some adhere to the idea of a single, objective reality, while others embrace the notion that the quantum world is inherently probabilistic, with the observer's role amplifying the complexity. The double-slit experiment, once a straightforward exploration of particle behavior, evolves into a philosophical battleground. The interpretations of quantum mechanics become a canvas where scientists paint their perceptions of reality. As the curtain falls on this act, the unresolved questions linger, inviting us to explore the myriad possibilities that the quantum realm presents. In this intricate dance of interpretations, the double-slit experiment challenges our very conception of existence, sparking a quest for deeper insights into the quantum enigma. The laboratory, once a bastion of certainty, becomes a realm of uncertainty and speculation, beckoning us to embrace the mysteries that lie beyond the confines of classical intuition. The double-slit experiment propels us into a quantum wonderland, where reality unfolds with surreal intricacy. As scientists grapple with interpretations and theories, the laboratory transforms into a gateway to uncharted realms. In this quantum wonderland, particles defy the norms of classical reality, existing in states that challenge our intuitive grasp of the world. The very fabric of space and time seems to ripple with uncertainty, inviting us to peer into the cosmic tapestry woven by the dance of particles. As the experimental stage expands, scientists embark on a journey to uncover the fundamental nature of the quantum landscape. The laboratory becomes a portal to surreal quantum landscapes where particles exist in superposition, embracing a myriad of possibilities simultaneously. The double-slit experiment, once a humble apparatus, emerges as a key to the kingdom of quantum wonderland, a realm where the boundaries between observer and observed blur, and the very act of measurement shapes the unfolding reality. This surreal expedition into the quantum unknown challenges us to relinquish our classical comfort and embrace the profound mysteries that lie at the heart of the double-slit experiment. As the curtain descends on our exploration into the quantum cosmos, the double-slit experiment remains an enigmatic beacon, guiding us through the intricate dance of particles and waves. The laboratory, once a realm of certainty, transforms into a haven of uncertainty and curiosity. In the lingering echoes of the quantum stage, we find ourselves standing at the crossroads of reality and possibility. The double-slit experiment, with its quantum choreography, challenges us to embrace the unknown, to question the very essence of our perceived reality. As we exit this cosmic theater, let the mysteries of the quantum world linger in our thoughts, a reminder that, in the quest for understanding, the dance of particles continues, inviting us to venture further into the enigmatic realms of the quantum cosmos. The double-slit experiment, with its lingering questions and unexplored territories, beckons us to embark on a perpetual journey of discovery into the wonders of the quantum universe. If you enjoy this type of content, please be sure to like and subscribe. If there are other topics you would like us to tackle, please let us know in the comments section below. Thank you for your support. Sweet dreams.